Welcome back to your Artificial Intelligence course. Today we'll develop a basic understanding of the principle and methods of machine learning, one of the most prominent approaches in artificial intelligence. Let's first clarify the terminology. So you all have probably heard many buzzwords including machine learning, data science, data mining, data analysis, statistical learning, knowledge discovery in databases, pattern discovery, and so on and so forth. So they all fall under the same umbrella, which is learning from data, how to do science with data. So the term data mining tends to disappear today. It was coined in the mid-90s. Today we talk more about data science. All this terminology is being unified under the data science terminology, which is how to make science with data. What motivated the field of data science is that data today is everywhere. For example, Google processes 24 petabytes of data per day. Facebook processes 10 minutes of photo every hour. YouTube, we have about 1 hour of video uploaded every second. Twitter, about 400 million tweets per day. And in astronomy, for example, satellite data is in hundreds of petabytes. It is estimated that by 2020, the digital universe will reach 44 zettabytes of data. That is 44 trillion gigabytes. That's huge. So data comes in different types and flavors. Data could be text, it could be numbers, click streams, graphs, tables, images, transactions, videos, and sometimes all of the above. For example, some websites would have a mix of all of these kinds of data. Okay, the fact is that today we are datafied. Wherever we go, we leave a trail of data. Smartphones, for example, are tracking our locations. We leave a data trail in our web browsing. We also interact a lot today with social networks, leaving behind us photos, comments, and so on and so forth, which actually makes privacy an important issue in data science. However, data science aims to make a good use of this data for the good sake of humanity. The data science process consists of 5 main steps. The first one is data collection. As I said, data comes in different flavors, so you could do data collections of data that is static, dynamic. It could be structured in databases. We also need to collect information about domain expertise. This is crucial to be able to understand the domain in order to be able to leverage this data and turn it into knowledge. The second step is data preparation. It's really where the data comes clean and ready to be used. So data preparation consists in doing some data cleaning, removing spurious, for example, information, and creating some features or variables, do some feature and variable engineering. So the outcome of this step is some curated data that is almost readily available to be fed into machine learning and statistics methods. The third step is exploratory data analysis. This step has been there actually in statistics for a long time. It's about exploring your data with different charts and curves and understand what we have received. It also allows us to ask the right question. Given the data we have received, first of all, do we have enough? Do we need to collect more? And second, what are the questions we want to have answered with this data? So after these 3 steps, we should have a clean data set that's come out of it, along with focused and interesting questions we want to address. So then comes the step of machine learning. Machine learning is the core step in data science in which we deploy machine learning methods and statistics methods to get knowledge and to learn models from the data. So these models could be either classification models, clustering models, regression, density estimation, and so on and so forth. So we have our data. From this data, we extract models, and we hope that these models are good to make predictions, to help us make better decisions. So the results of machine learning are in general visualized with the curves to show the performance of the models. It also could be mapped on a map if it's a special temporal data, and also deployed in real life. So the hope is that we acquire knowledge from this data, and sometimes we need to refine the process a little bit. So we go back into the main step, possibly including more pieces of data and refining the process until we are satisfied with the knowledge that we have learned from the whole process. We have seen that machine learning is one of the core steps in the data science process. So now, what are the applications of machine learning? we all use machine learning on a daily basis, sometimes without even knowing it. For example, we all use emails, right? So emails, in our emails, we sometimes get spams coming into our inbox. But as the times goes on, spams are being filtered by your email system, because there is a smart machine learning piece behind it that learned how to classify good emails from spam emails. And this is all hidden to you. It's in the email, embedded in your email system. Machine learning is being applied also in fraud detection, in recognizing digits on checks and zip codes. It's also used in detecting faces and images and analyzing MRI images. Machine learning is also the core of recommender systems, search engines such as Google's, and handwritten recognition, along with many other applications. Another interesting fact is that machine learning is an interdisciplinary field. There are many different fields that contribute to machine learning. This include biology, engineering, signal processing, databases, economics, visualization techniques. In particular, the connection between machine learning and statistics is very strong. Let's look closer into this connection and clarify how machine learning relates to statistics and data analysis. So this is actually a decade-long question about the connection between the two fields and whether machine learning and statistics should be separate fields or should merge ultimately as a one single field. The fact is that they are two complementary fields with different visions and terminology, but do have a lot in common. And what they have a lot in common is data. Both fields care about data. They both provide a set of analytical tools and methods with some overlap. For example, probability-based methods exist both in machine learning and statistics. We talk in statistics about feeding models, whereas in machine learning we talk about learning models. Statistics care about topics like hypothesis testing, experimental design, methods like ANOVA, linear regression, logistic regression, GLM or generalized linear models, principal component analysis. Machine learning cares about computational modeling and high-dimensional spaces. It includes advanced nonlinear techniques such as support vector machines, neural networks, deep learning, that use actually special geometry rather than probability methods. Other techniques include decision trees. Decision trees were both invented in the statistics community and also in the machine learning community. Other techniques include rule inductions, clustering methods, association rules, feature selection, visualization, graphical models that are based on probability, genetic algorithms, etc. So for an interesting contrast between machine learning and statistics, or data mining and statistics, I refer the viewers to these interesting articles from interesting articles about that. So finally, can we find a good definition of machine learning? So according to one of the founders of machine learning, Professor Tom Mitchell, machine learning is about how do we create computer programs that improve with experience. So more specifically, a computer program is set to learn from experience E with respect to some class of task T and performance measure P if its performance at task T as measured by P improves with experience E. So here, Professor Mitchell made it clear about what is learning, in the sense that we talk about experience E with some respect of class T. So we want to solve some problem. We have some task to achieve. So for that, we have some experience E, and this experience comes in terms of data. So we say that a computer program is capable of learning if its performance, right, measured by measure P, at doing task T using E, right, improves with the experience, which means that the more we have data, the more our computer program will be able to learn and do a better job at doing some tasks T. So I think this is a very compelling definition of machine learning.